My name is Enrico Nardone. I'm the director at the Seatuck Environmental Association. We're a nonprofit based on Long Island that works to conserve Long Island wildlife. And one of our flagship projects over the last 15, going on 20 years is focused on diadromous fish and reconnecting rivers and streams and trying to restore them to their integral role in our coastal ecosystem. So these fish, the word is diadromous fish. It's a Greek word, which means the prefix means run. No, the prefix means through, and the root of the word is run. So these are fish that run through from one biome to another. They split their life cycles between freshwater and saltwater. And that might not seem like such an amazing thing, but it's really pretty amazing and really unique. Of the 32,000 or so species of fish on the planet, only about 400 fall into this category of diadromous. So most fish are either freshwater fish or saltwater fish, and can't exist in the other habitat. You take any sort of freshwater fish and put it into a pond, it would die within a few minutes, and vice versa, because the chemistry is all wrong. But these diadromous fish manage to go through from one type of water to the other, and in some cases almost immediately without any sort of an adjustment period, which is really pretty remarkable. And there's some sort of questions, sort of unanswered questions, largely as to why and how and why diadromy exists at all on the planet. And there's some theories as to perhaps it's an in-between stage, that all diadromous fish are in the process of transitioning from one either freshwater or to saltwater, or saltwater to freshwater. But the research seems not to be playing this out, that diadromy exists across a range of different parts of the evolution of fish. So lots of different families have diadromy. It's not sort of limited to one kind of fish. So there seems to be a sense now among scientists that it's an evolutionary strategy that's happened over and over again, and is not a transitionary state, but is a permanent evolutionary stage. So I was no luck with that loading.
So I have downloaded it onto my computer now, and now I'm trying to share my screen, and I'm getting some obstacles.
So I'll just keep going on this then. So
I'll keep trying to.
You all know the most famous diadromous fish, which is the one that we see on the Discovery Channel, jumping up waterfalls and evading grizzly bears. Oh, good. Yeah, you can just dance through this.
Great job.
So
Thank you, Sarah.
Yeah, right.
We'll make it work. So yeah, just
yeah.
the diadromous, you can skip this. I already did this through running.
Don't know.
This is what makes something diadromous. So fish that move between these two different types of water, but they do it predictably. So it's not just a fish from the river that gets carried downstream and ends up in the bay. And it's not just some fish, it's all categories of fish. And it happens both directions. So it's usually they're going from freshwater, saltwater, or saltwater, freshwater. And it involves both of those as part of a life cycle. So you want to just go back, yeah, you can stop here. So this is, on that chart I had, there's what scientists say 3 categories of diadromy. I'm really going to discuss 2 of them, but yeah, so the third one, and the amphidromous fish, are fish that migrate in some level between salt and freshwater, but not for breeding purposes. And it's a much smaller category, and there's none in New York. They're mostly tropical fish. So I'm going to focus on the other 2, and I'm going to run through I'm going to touch on some of the species, but I'm going to mostly focus on 3 species that exist on Long Island because that's where I work and these are the fish that I know. But so the first category is anadromous. So if you want to click the next slide. These are the famous Pacific salmon. They're anadromous fish. Next slide. We have others in the neighborhood here in New York. So these are fish that spend most of their lives in freshwater. In saltwater, but migrate into freshwater to spawn. So these are all fish that are too small to be on Long Island, but are migrating up the Hudson River to spawn. The famous Atlantic sturgeon, giant fish. If you want to pan through, I think I have some slides of these. Next slide. Next slide.
That's great.
This is the sturgeon that can grow 15 feet long. Striped bass, which are famous sport fishing fish. Next slide. And I think I have shad next. Oh, this is a video. You could skip the video. Shad. Next slide. So the shad are, go back to shad, that last slide maybe. Shad are in this family of allocenes. These are sort of category fish that I'm going to talk about a little bit. These are all fish that are in the Hudson River and other rivers upstate. The 2 smallest ones are on Long Island. The biggest, American shad and hickory shad, we don't get down here. But these fish all share the same life cycle. They spend most of their lives on the continental shelf in some schools up and down different ranges of the continental shelf, different depths, but they're all moving into freshwater to spawn. And then they spawn, and unlike some salmon species that die after spawning, they spawn and then they return back to the ocean. They're not nest builders. They're broadcast spawners, and they return to the ocean, and they can make that trip 5 or 6, 7 times in the course of their life. Next slide.
You guys see that message that my free meeting end in 10 minutes?
No.
I don't know what that is. I'm on my school account. I don't know why it would be ending. Okay, well, next slide.
Just have to come back on.
Sorry.
Okay.
I'm looking for my cursor so I can.
You hit the right arrow key, should move it.
Yeah, I was doing that. I have to. Okay, now what? No.
So the river herring are the 2 species that I mentioned there are, they're not it's not a species, it's a category of these fish, and it has a category of 2. One is alewife and the other is blueback herring. These fish are easy to tell apart in a nice illustration like this, but in the field, they're very difficult to tell apart. And so at least on Long Island, we categorize it, we group them together, and we refer to river herring. And we don't even ask our volunteers to try to make any distinction between the 2. But scientists in the field, when they're holding them, can usually tell. Next slide. So these fish, you can see like they're difficult to tell apart. If one is which in that picture.
They're very
Next slide. Yeah.
I think the top one is alewife and the bottom one was the other one.
Yeah. So these are, again, schooling fish. They're on the continental shelf in depths of like up to 200 feet, often in mixed schools, which we'll touch on later, with mackerel, Atlantic herring, and moving around until they start to stage. Next slide. They move into the estuaries in late winter. Next slide. And then when the time is right, they move into fresh water to spawn. And I have time in quotes here because next slide, it doesn't, and then nothing to do with the calendar. It has to do with temperature. So when the water flowing down the rivers gets sort of approaching 50 degrees, they say 48 is sort of the magic number, but that's the temperature they're looking for. And they move into the river to spawn. But it's not like a one-time thing. It's not like a switch flips though. The temperature could change with cold weather snap comes in, they move in. But in the past 5 years or so, scientists have learned that there's a lot of pulsing that happens, especially on Long Island with smaller rivers, where they move in, they move back out, they move back in. And they spawn. They're only, once they settle in and start spawning, they're only there for a few days. And once they're finished, again, no nest building or caring for young. They're back out onto the continental shelf and joining schools again. Next slide. Let's just skip some of the video because we know we're short on time.
So skip.
This is what they look like when they're in freshwater. This is the Mill River in Rockville Center. You can, if you want to just let this play a little bit, if it will play on the Zoom. Sometimes it doesn't work that well. But you get an idea what they look like together. This is like their spawning behavior. They're kind of circling around each other. You can hit the next slide. I want to point out, yeah, next slide is a map, I think. These fish are in Rockville Center on Long Island, which is this river. And I say if there's a river that's been more poorly treated than this one, I'd like to see it because it's been impounded like 5 times. It's part of Hempstead Lake State Park. It goes through a very industrial and channelized area downstream near the bay. And then it goes under these Sunrise Highway, Merrick Road, and the Long Island Railroad, 700 feet underground before it gets to this dam at Smith Pond. And that video that I was just showed is at that spillway. These fish have gone all the way underground like that. Most biologists that we talked to about we were exploring putting fish ladder in here, and they said, no, they don't go underground that far. But here they are. And they're a really resilient species. This species, they've been breeding in this river for, thousands and thousands of years. And despite all the damage we've done to their habitat, they're still trying to come in. But they're reaching suboptimal conditions. Water quality is not what they need. Substrate is not what they really need. But they're still persisting and hanging on. But their numbers are continuing to drop. So a big effort is now sort of being made to kind of help these fish rebuild their stock. Next slide. You can skip this one. This is just showing some more breeding behavior. They reach really small streams like this.
You want me to skip it?
Yeah, skip that one. Next, yeah, each female can lay 250,000 eggs. Go right to they hatch these really super cute little fish that can spend a couple months or several months in fresh water, usually moving out into the estuary on storm events. Next slide. But by the time they're about 3 inches long, they're finding their way back to the ocean. They school up with other fish of their year class and eventually with other adults. And at the age of sort of 3 to 5 years, or sometimes with females a little older, they move back in and start their first run as spawning sexually mature adults. And they have an interest in returning to their natal stream. They don't always get that right. They stray sometimes a little east or a little bit to the west, but they're trying to get back to the stream that they hatched in. Next slide. And eventually, yeah, joining the schools out on the coast. Next slide.
Oh, sorry.
So those are diadromous fish. Quickly, catadromous fish are the opposite. They spend most of their lives in freshwater, but hatch in the ocean and return to the ocean to spawn. We only have one in New York. Next slide. This is the American eel. And this is an even more amazing story if you don't know it. Next slide. I know we're short on time. These fish, they all American eels and all European eels hatch in this part of the North Atlantic called the Sargasso Sea. It's the only sea in the world not bound by land, and it's not a small area. It's 3 times the size of the Mediterranean, and it's this area in between the big North Atlantic currents, and they all hatch there. Next slide. They're planktonic. They don't have eel shape. They start as sort of these willow-shaped leptocephali, and they are on currents and they're being moved up. First they sort of, I think the next slide shows some movement. Yeah, they sort of drift with the sort of primary currents to the west. Some end up in the Gulf of Mexico, some in South America, and then others catch the Gulf Stream and move up on the Gulf Stream. They get bigger and bigger, and eventually, as they get over the continental shelf, they transform into more of an eel shape. But amazingly, the European eels keep going across on the Gulf Stream, across over to Europe. And scientists used to think that they were the same species, just a question of where they got off the merry-go-round. But now they've determined that they are actually genetically different species, and somehow the European eels know just to stay on the merry-go-round and not get off the ride and keep going to Europe. Next slide. They move into fresh water. This is what they look like when they're still not eel shaped. That's the leptocephali. They have no pigment. Next slide. This is what they look like when they move into fresh water. This is on Long Island. They've now assumed that eel shape. They don't have any pigment yet. They only gain pigment once they really stay in fresh water long enough. And they're called glass eels. These are some of the most valuable fish in the sea because they are collected to be taken to Asia to be grown up to be full eels for the Asian cuisine for market. They sometimes fetch $2,000 a pound. Because of this crazy life cycle, they can't reproduce eels and they get them to spawn in captivity. So they can only grow eel. Any eel that's eaten anywhere starts its life in the wild somewhere.
Can I interrupt for a second? So
Yeah.
I'm getting a message that my free meeting is going to end pretty soon. If that happens, I recommend everybody exit the room and then go back and click on the link and we'll just start a new meeting.
Mhm.
And we'll pick
Will
up
do.
where we're- I apologize.
Okay, next slide.
Okay.
Next slide. You can see,
Pass
yeah,
this.
this is more eel. These are eels with some pigment. You just want to show this, just how dense these migrations can be. When these eels pulse in, sometimes there's lots and lots of them. This is thousands and thousands of eels in a spot on Long Island.
And is this during a very limited time?
Are we out of time, or should I keep? Yeah, I can keep going.
I mean, no, you have 15 more minutes to talk. It was a Zoom issue. Let's go back to my screen sharing of your slideshow. So did you hear my question at the end? Like I said, for how long are these little glass eels doing their thing? Is it days, weeks?
It's weeks, or months. It happens we start seeing eels on Long Island at least in late February, mid to late February, depending. It's sort of temperature driven too, also. So and then it continues in some places, for about sort of 2 months, and by May it's sort of done. But it's not very regular. They kind of come in impulses. I don't really know a lot about what drives that. I think it's sort of based on tides. They definitely move on high tides that we see here and temperature. So sometimes you can go one day and see none, and the next day and see thousands.
Wow.
But they're mostly getting stuck at the dams. And you want to go to the next slide? I think I show they do have, they're like snakes. If they have 2 points to hold on to, they can sort of sometimes climb. That's about how big they are when they come in. Next slide. I think there's a video here with them climbing. At one time, they were in every freshwater stream on the East Coast, up into Canada, down through the Gulf of Mexico into South America, all the way up the Mississippi system.
That's amazing.
But their range is shrinking on both sides, and once they get into freshwater, they become, and they get some pigment. They're called elvers. And then after the first year, they become their sort of primary adult stage, which are called yellow eels. And they could be about that big. I think the next slide is a video of a yellow eel moving. I took this video. My neighbor was cleaning some foliage on the edge of the stream and flood. They're mostly not, it's very unusual to see them during the daytime like this, but it got flushed out of its hiding spot. They're mostly nocturnal, and they kind of nestle in under leaf litter and into the muck during the daytime. But it's not going to play that well. But you can still see how they they're great predators. They eat just about everything, and there's a lot of them. They say in any healthy riverine system, and North America, they make up as much of us and more of the biomass as any other fish. All right, next, you go to the next slide. That's just more of the video.
Oh my gosh.
So, and they can keep growing and they stay in the systems for 10 to 20, sometimes maybe even 30 years. And they can get 4 feet long or so. And at some point, and again, scientists don't know exactly what triggers it, but they go through their final transformation into what are called silver eels. And that's the sexually mature migration phase where their eyes actually get bigger, their fins grow, and they prepare for this final swim of their lives back out to the ocean, to the Sargasso Sea, and somehow find all their kin out there and spawn. Scientists have never seen an adult eel in the Sargasso Sea. They've never seen the spawning behavior, but eels have been tagged both from the States and from Europe, and they've satellite tags. They know they go in that direction, and they also know that's where they find the most and the smallest larval stage eel. So it's really one of the mysteries of science as to how it all happens. But next slide. Yeah, next slide. We covered that. This is just, that's an interesting thing. This migration, the migration to the ocean happens in the fall. And I grew up on this is the Susquehanna River, and you can see this sort of shape, this pointed arrow sort of shape, pointing downhill. And this is an eel weir, most likely built by Native Americans. They've dated them to be thousands of years old. And the eels, when they're doing this migration in the fall, they're swimming downstream. These weirs gotta collect them and point them into what would have been a structure at the point of that arrow, where they would be pushed into these nets and buckets, and that's how they harvested them. So these eel weirs are a common sight. They've started using satellite imagery to find them. But when I was a kid and fishing in the Susquehanna River, we just knew these structures as great places to fish. Didn't know why they were there. We thought they were just natural formations. But next slide. That's another one. Next slide. Next one is in the Delaware River, looking up. You can really see this is what the nets would have looked like, and this is one where they're actually currently still harvesting eels on their downstream migration. Next stream. I mean next. And then so why are these fish important? People ask, well, I don't, especially about river herring, like that. Not many people eat them. They're grossed out by eels, but they're an important part of the, I mentioned eels of the human diet. I know you would say that there's a debate about whether there was turkey at the first Thanksgiving dinner, but there was certainly no debate about whether there was eel, because eel was a staple of Native American and early colonial diets, and Thanksgiving time is exactly the time when they would have been available during their fall migration. Next slide. But it's not just people, it's everything else eating these fish. So these are all big oceanic predators eating the adults as they're in the ocean. Next slide. And then they move into the estuaries, the river herring in particular, feeding lots of other fish and marine mammals and certainly birds. Next slide. And then into the rivers, where there are another host of predators waiting for them. Next slide is on the osprey. The osprey migration is sort of famously timed to these runs as the migration, which starts further south, moves north. That's sort of as the osprey go with them. Next slide. This is a bird called the herring gull. You can see these birds lined up along streams when the river herring runs are on. Next slide. There's the osprey. Next slide. So, and then each female, as I said, can lay a quarter million eggs. Each one of those eggs is a sort of little packet of energy, which is feeding lots of other fish and invertebrates in the stream systems. So they really, we say, like, they help to drive the coastal ecosystem, and not just river herring and eels, but all diadromous fish, because of their the very unique thing about their life is that they're moving from the oceans into the estuaries, into the rivers at some part of their life cycle. And in doing so, they are transferring energy. They are transferring ocean-derived energy into these other systems. And it's a very essential thing that they do. And part of why they're so ecologically significant and why so many conservation organizations are trying to help them, because we really do rely on that energy transfer to drive and make sure our estuaries and uplands are healthy. Next slide. How are they doing? They're not. This is always a picture of it looks to me like a frowning alewife. Next slide. They're not doing well, and the part of the problem is they're they split their life cycle in these two places, so they have problems in both places. And one of the big problems they're facing when they're offshore, this is true about river herring, shad, striped bass, lots of things that are getting pursued either commercially or are getting caught up as bycatch in other commercial fisheries. I mentioned that river herring swim often with mackerel and Atlantic herring. Those are targeted species, and they're getting caught up. I have these slides in here because I like to make people, when I say offshore fishing, people, you might think of the guy with the yellow rain jacket on or a small family fishing operation. These are not the kind of offshore fishing problems we have. Next slide. This is what modern offshore fishing looks like: is 200-foot pair trawlers dragging nets that are football fields across for hours and hours on end. Nothing survives this process. Everything that gets pinned into these nets dies, and there's lots of non-target species being caught. So these diadromous fish are getting hit offshore. And then the next problem they have inshore is that we haven't really done a great job of taking care of the habitat they need when they come inland into fresh water. Next slide. We've developed shorelines, degraded water quality, and most significantly for migratory fish, we've built lots of dams to power grist mills, sawmills, harvest ice, support cranberry production. So this is a major problem. These fish, at least on the Atlantic side, are not jumpers like the Pacific salmon are. They can't jump up waterfalls. This is a 5 or 6 foot dam is an absolute barrier, but even a 2-foot dam is an absolute barrier for them. Next slide. I think I have a video here. No, I said, well, they all might as well be the Hoover Dam. This is video. If you want to go to the next one, this is a river herring trying to get up. It looks to me about, I don't know, 15 or 18 inches of a dam here. And it's not going to play well on the Zoom call, but they're struggling and they're trying over and over and over again. You could watch this for hours, and they just can't, as much as they try, they can't manage that. They're very capable swimmers with a very high burst rate, but they need to swim inside of a water column. This is a video showing that eels, on the other hand, can climb.
Oh my gosh.
I said they have their pinch,
Yeah,
they
wow.
can hold on to 2 points, and there's some texture to the surface. They can climb, but I've watched this behavior for hours, and most of them fall back. It's a tall task for them to climb up even that 2 feet there. And so we significantly reduce the eel migration with dams as well. Next slide. This is the dams, why we built them all. Mills. Next slide. You can flip through these: cranberries, ice. Next slide. So what we're at least trying to do on Long Island is get fish past these dams. We've had only success with fish ladders. So these are structures that create that slow down the water and give the fish a chance to swim past the dams. Next slide. This has been done increasingly around the world. You can see it here with the baffles inside that slow the water and give the fish a chance to swim up. Next slide. These structures can get really complicated. This is one in upstate New York where it's a whole big bypass channel. Next slide. But sometimes they look like this is called a nature-like fishway. It looks like a stream, also very much engineered, though. Inside of that stream are rocks that do the same thing the baffles do, which is slow down water in places so the fish can navigate. Next slide. This is an eel-only path with the simple PVC pipe with some netting in it, so the eels can more easily climb up the netting. Next slide. Next slide. That's the eels using the pass. You can skip that one, Cindy. But this is what I was trying to get to. This is the we're trying to get to on Long Island. This has been happening in upstate New York and Pennsylvania and lots of places around the country, is moving past the legacy of these dams that were not serving any of their original purposes, and fully reconnecting rivers in a way that no fish pass is capable of doing. So you want to make a fish by removing a dam, you make it possible for not only all fish to move past, but all other species, and for sediments to move downstream and nutrients to move. So this is an important undertaking that is, again, happening around the country and thankfully in parts of New York, but we need to see a lot more of it. So that, you know, I would, if we're out of time, I would just close by saying that we just drive home this point that they are an important ecologically significant because of the energy transfer, that they are an important part of not just the marine habitats that they use, but also the freshwater habitats. And reconnecting these streams will allow these fish back to play the important ecological role they always have.
Awesome. We made
That was
it.
great.
Woohoo.
Thank you, Sarah.
Yeah,
Thank
I'm
you.
amazed that all went as smoothly as it did. Thank you, Enrico. That was amazing. I feel a little bad because we did get a
My
late
pleasure.
start. Does anyone have
Yeah.
any questions? We could spend like 1 or 2 minutes.
Oh, I just have one quick question. I've seen fish transfers where they get sucked up by pipes and tubes.
Yeah.
And I wonder how safe that is for the fish when they come out on the other end.
Yeah, I don't know. That's been done on the big hydroelectric dams out west, and I think they move salmon that way. And I think it seems like they survive pretty well. But you know, as I said, like no efforts at fish passage work as well as removing dams and restoring full connected rivers and streams.
Right.
I understand. I don't know much about those systems, but you should, if you haven't seen it online, you should. They call them fish cannons. You should look at it. Pretty amazing.
Cool. Anybody else?
I would just make the last thing. It was that I had a picture there of our flyer we have for our annual survey, where we send dozens or hundreds of volunteers around Long Island looking for these remnant runs of fish and counting them. And it's a great way to involve students and the eel. You know, you can put eel mops out and trap eels and help them over dams or engage students in this really amazing story, because it's a way to connect people to their waterways and this sort of really neat annual migration that's happening.
For sure.
Yeah.
Chris Bowser, some of you know him, does eel counts, I think, right?
Yeah, they have a great program in the Hudson River with students counting eels. Yep. He's one of the great advocates for eels, especially. If you haven't had a chance to hear him talk, I encourage it.
Yeah. He's been a presenter at past conferences for us.
Yeah.
All right. Well, thank you so much.
Yeah, I just want to stress, can you hear me clearly?
Not clearly. It's a little broken up. You want to put something in the chat?
Enrico working on this, and for years, the volunteers have been fantastic. It's fine dream that we didn't know these migrations exist on South Shore.
Yeah.
Yeah, because the runs are so brief, and it happens at a time of year where it's still not always that pleasant to be outside. Even here in Long Island, we're still finding, we call these remnant runs. Every year we find them in streams we didn't know they existed. So that's probably true up and down the Hudson and other places as well. But even in places where you know they're there, it's still, I mean, people are still amazed to see them, and to stand in somewhere in a small stream and see fish that have come from thousands of miles away, potentially out in the ocean to be there. It's something really exciting about it, and really does seem to move people and connect people to the waterways.
Sure.
Do we have time for one more question?
Sure. I guess so. Sure.
Quick, real quick. The glass eels that are collected, they're mostly to be grown up to be adults, as opposed to directly being eaten as food.
Yes, they're grown to be adults. I mean, I should say there's no legal harvest in New York, although there is poaching. The only places in the States is Maine. There's a brief harvest season in Maine and a brief in South Carolina, but they all get sent to Asia to go into the aquaculture facilities.
Thanks.
It's cheaper to send them at the small stage than when they're 4 feet long, right?
Yeah, and there's a lot of pressure on the American eel because the European eel and the Asian versions have been mostly fished out of the sea and are doing even worse than ours are. So there's we have poaching problems on Long Island all the time with people catching them illegally.
Lisa, you're muted. We can't hear you.
Enrico, this is very interesting, and I just want to say I attended your Long Island Natural History Conference last weekend. It was fantastic, and NYSMEA would like to connect with you more in future.
Love to do that.
Awesome.
Thank you.
Let's talk.